All right, so the first few slides we went over in part 1, which is the remainder theorem. So we know that we can do synthetic division with this number on the outside, and whatever our remainder is, that's that value that we would get if we plugged in this -2 into our equation. So we've done this example, what was that, last week on Friday? So I'm going to skip that for now.
Ms. Carver, you're not screen sharing.
Thank you. Okay, and same with this example, we did it in part 1 also, which we can do synthetic division when x is equal to 2 and x is equal to -3. And if our remainder is 0, then these would be factors of our polynomial. So we did this in the other notes also. So today we're going to look at the rational zero test. So if we're given a polynomial, we can take our constant, which is p, and put it over the coefficient out front, which is q. So this number is going to be p. The number out front is q. So we take all of the factors of our constant and put it over all the factors of our leading coefficient, and we can test those to see if they are rational zeros of our polynomial. So we're going to do some examples. So again, here we have factors of the constant term on top over the factors of the leading coefficient. So we need to find the rational zeros of f of x is equal to x cubed plus 8x squared plus 11x minus 20. So we need to start by listing all of our factors of -20 and then all of our factors of 1. So we put the factors of our constant on top. So what are our factors of 20?
10.
2, 1, 2, 10, yeah, 5, 4, and I think that's it.
What's
and 20.
And 20.
Yeah, 20.
And we have the plus or minus of all of these, and then what are our factors of our coefficient?
1.
1.
Yeah. The leading one.
What number are we going to start with for our synthetic division?
Well, +1.
+1. It's always best to start with +1. But we could start with any one of these options if we wanted to. So let's try 1. Our coefficients are going to be 1, 8, 11, and -20. So when we divide synthetically, we have a remainder of 0. Perfect. So 1 is an option. 1 is one of our rational zeros. So now our polynomial that we have is x squared plus 9x plus 20. Can we factor this?
Yeah. X
Yep.
plus 4, x plus 5, which would be x equals -4 and x equals -5.
Awesome. So these are 3 zeros for this one. And if we look at our leading exponent, we have x cubed, so that tells us we're only going to have 3 zeros. All right, let's take a look at the next one. So we need our factors of our constant over our factors of our leading coefficient. So our factors of our constant are what? What's our constant?
Wait, isn't it?
Negative 6.
Yeah, -6.
Negative 6.
Sorry.
So what are factors of negative 6?
1, 2, 3, and 6.
Perfect. We have the plus or minus of all of these. What are factors of our leading coefficient?
Plus or minus 1.
Perfect. What should we try first?
Oh, you put 1.
Let's try 1. So we have 1, 2, -5, and -6 inside of our box. And we just do synthetic division. We do not get 0 as our remainder, so 1 does not work. So we have to try something else. What's something else that we can try?
-1.
Let's try -1. Again, in our box, we have 1, 2, 5, -5, and -6. We get 0 as a remainder, so -1 works. So -1 is one of our zeros. So now we're left with x squared plus x minus 6. What are two factors of -6 that add up to -1?
X minus 6 and x plus 1. Oh, wait, no. Oh, x plus 3, x minus 2.
So if we have a positive 3 and a -2, yeah, that gives us positive 1. So x minus 2 and x plus 3. So x is equal to 2 and x is equal to -3. So our other zeros here are 2 and -3. We have one last example. All right, let's look at our first example. So what are factors of 12?
Do we have to list them out?
Yes.
So 1, 2, 3, 4, 6, 12.
Perfect. And we have plus or minus of all of these. And then what are factors of 1? Just plus or minus 1. Yep. So now we can test out each of these possibilities. So we would have 1 over 1, which would just be 1, 2 over 1, which is 2, 3, 4, 5, 6, 12, and then all the negatives of those two. We can test all of these through synthetic division. If we get a remainder of 0, then it would be a factor of our polynomial. It's always best to start with 1. If you wanted to start with 6 and try that, you could. If you wanted to start with 12, you could try that. But it's always best to start with 1. And then we just do synthetic division with 1. So we have 1 on the outside, and then we plug in all of our coefficients of our polynomial. So we have 1, -4, -13, 4, and 12 on the inside. We do synthetic division here, so we drop down our 1. 1 times 1 is 1. One times -16 would be -16, so it'd be -12. So we get 0. When we get 0, that means 1 is a factor. So here, a factor of this would be x minus 1, or we could say x is equal to 1. So 1 would be one of our rational zeros. How many rational zeros in total are we going to have here for this polynomial?
4.
4. Remember, we look at our leading exponent, and that tells us how many we have. So we have 3 more that we need to find. So now we're going to take what we found in synthetic division and set that up as our new polynomial. So we have x cubed minus 3x squared minus 16x minus 12. After we use synthetic division, we can see if we can factor. So once we divide, then we can try to factor. If it doesn't factor, then we can do synthetic division again, and we can pick another number from up here, another one of our possibilities up at the top. So can we factor this polynomial x cubed minus 3x squared minus 16x minus 12?
Yes.
What would it factor to? How do we factor it?
You have to take out an x, right, and then go from there.
Can we take an x out of everything?
Oh, no, you can't because it's a 12.
Right.
So then you just leave it like that.
So if we can't figure out how to factor this, we can try another number. So what's another one of our possibilities up top that we can try?
-1.
Let's try -1. So now we're going to use our coefficients from this one here. So we have 1, -3, -16, minus 12. So this would be -1, -4, +4, -12, +12, and then 0. So we get 0 for our remainder again. Did I do that right? Everybody with me so far? So
Yes.
if we get 0 for our remainder again, that means -1 is also going to be a rational 0. And now our new polynomial is x squared minus 4 minus 12. Can we factor this?
Yes.
Yeah. What are two factors of -12 that add up to -4?
-6 and +2.
-6 and +2. So we have x minus 6 and x plus 2. So when we set each of these equal to 0, we get x is equal to 6 and x is equal to -2. So two more factors are 6 and
Miss
-2.
Carver?
Yes.
Wouldn't it be x squared minus 4x, right?
Yeah.
Like, oh, that's so bad.
Yeah, I just forgot the x, but yes.
Thanks.
So our four factors of this equation are 1, -1, 6, and -2.
Miss Carver,
Yep.
do we need to put the answers in order?
On WebAssign, I think it'll tell you to put them in order, I think. So if it asks you to put them in order from least to greatest, you just have to put -2, -1, 1, and 6. So WebAssign might be picky with that. So what are factors of our constant?
Plus or minus 1?
Plus or minus 1. What are factors of our leading coefficient?
Plus or minus 1?
Plus or minus 1. What should we try first with synthetic division?
Positive 1?
So let's try +1. So our coefficients are 1. We don't have an x squared here, so we need to put 0 in that place. And then we have 1 and 1. So we have 1. 1 times 1 is 1. 1 plus 0, 1. 1, 2, 2, and 3. Is 1 a rational zero?
No.
No, because we need our remainder to be 0 in order for it to be a rational zero. So 1 does not work. What can we try next?
-1.
All right, let's try -1. So in our box, we have 1, 0, 1, and 1. Does -1 work?
No.
Nope. Do we have anything else left to try?
No.
Nope. So for this one, we have no rational zeros. So there are no rational numbers that would make this function equal 0. All right, let's look at the last one. Any other questions on this one? All right. How many zeros are we going to have here?
5.
5. What are our factors of our constant?
1, 2, and 5, and 10.
1, 2, 5, and 10. We need the positive and negative of these. And then what are our factors of our leading coefficient?
Plus minus 1.
Perfect. What can we try first?
Positive 1.
Let's try +1. So in our box, we have 1, -3. We don't have an x cubed, so we need to put 0 in that place. And then we have 7. We don't have an x, so we would need to put 0 in the place of x. So we are just including a 0x cubed and a 0x. And now we divide synthetically. So we have 1 times 1, which is 1. 1 plus -3 is -2. 1 times -2, -2. Is 1 an option? Does 1 work?
No.
No. So what else can we try?
-1.
Let's try -1. So we have -1 plus -3 would be -4. One times -3, -1 times -3 would be 3. Does -1 work?
No.
Nope. What can we try next?
2.
Let's try 2.
No.
Nope. What can we try next?
5.
Let's try 5.
5 didn't work.
5 didn't work. What else can we try?
-2.
Let's try -2. I wrote these too close together. So then we have 26. -2 doesn't work.
Try 10.
Let's try 10.
Oh. Might be an irrational.
Yeah, this one's not gonna work. What else can we try?
Last one, negative.
No, it's 0. There's no way.
Yeah, negative 5 didn't work, I guess. Or negative 10.
The only one I haven't tried is negative 10.
Yeah, I
Oh,
don't,
so-
negative 10 wouldn't work either. It would just be too big. So this one would have
Yeah, so it's 0.
Yeah. No rational zeros.
no rational zeros.